Hey everyone, thank you for joining this Lunch and Learn today. My name is Enzo Zenuni, and I'll be briefly covering a few of the differences between graph databases and relational databases. I'll also go over some key highlights of the two, when to use graph, what to consider, and what to look for when starting your next project. So, graph versus relational. A database is a critical key component of any software application, and choosing the right database can make or break a project. You don't want to get into a technology stack that's not going to be able to grow or scale with your project. See, there's a variety of different database technologies available, and last time I did some research on this, I think it came around the number of 350, give or take a few, and that's overwhelmingly a lot of different options to go through. Now, each of them with their own advantages and disadvantages, but relational databases are the most common type of database, and they're well suited for applications that already have well-defined relationships between different data points. Now, graph databases, on the other hand, they're designed to store and query data with complex relationships. Graph's a type of database that uses graph structures for semantic queries, with nodes, edges, and properties to represent and store data. You see, graph databases are different from relational databases, which typically store data in tables. With graph, you have the advantage of being able to efficiently handle tons of data while maintaining relationships between the different data points. Graph databases, they excel at modeling arbitrary relationships between entities without losing sight of the bigger picture. You see, graph database technologies, they've been around for a long time, but it's just recently that they've been trying to gain more popularity because of recent advancements in hardware and software capabilities. So if you're considering using a graph database for your next project, here are some things to keep in mind. So what is a graph database? Well, it's basically a type that stores data in the form of a graph. In a nutshell, graph databases store schema-free objects, vertices, or nodes, where arbitrary data can be stored as properties and relations between the objects known as edges. See, edges typically have a direction going from one object to another or multiple objects. Vertices and edges, they form a network of data points, which is called a graph. But graph databases are generally more scalable and performant than relational databases, which makes them well suited for use cases such as social networking, recommendation engines, entity resolution, fraud detection, and many, many more use cases. Additionally, graph databases can be used part of a technology stack to complement existing relational databases as well. All right, so now what's a relational database? Well, I'm sure many of you already know, but a relational database is basically one that stores data in tables. The data in these tables is already highly structured and has predetermined columns of specific types. They're typically used to store data that's highly structured, such as financial data or customer information, and also like the one that you see here in this diagram. Relational databases, they've been in the stable of software applications and have been used since the 1980s. Now, while relational databases have served as a workhorse of software applications for many years, they are not without their share of troubles. You see, one of the biggest problems with relational databases is their lack of scalability. As data sets grow, they become larger and more complex, relational databases can start to experience significant performance issues. Additionally, the rigid structure of relational databases can make it really difficult to add new data types or change existing ones. And as a result, developers and applications often have to choose between flexibility and performance when working with relational databases. So now the question, when do you use a graph database? Well, before answering that, there are a few important things to consider here. First is going to be, how frequent are the changes in your data? Second, what's more important to you? Is it retrieving or storing the data? And then last but not least is, how connected is your data? So when taking all that into consideration, if your data is constantly changing, highly connected, and retrieving your data is far more important to you, then a graph database is going to be the way to go. So if you think about it, graph databases are more concerned about the data itself than actual schema structures. You see, when they store relationships between nodes in such a native way, it ends up making queries about relationships extremely fast and easy when compared to a relational database, for example. Now with ArangoDB's multi-model graph database, you can easily operate within the realm of any NoSQL data model, You can store graphs, documents, relational, key values, and even do things like full text search with fuzzy search capabilities. With Rango being built in C++, you can easily scale and maintain performance even in large databases that are in the range of terabytes or more. So when you're talking about RangoDB as a solution, we're a multi-model graph database that's powered by our query language AQL, which gives you access to all the different data models and graph all under the same engine and UI. So to sum all this up, if you're needing to handle complex queries fast, efficient, and scale while maintaining performance and flexibility, Graph's going to be the answer. But to really power Graph and fully take advantage of it, you should consider RangoDB's multi-model graph database as your solution. If you're interested in learning more or want to set up a demo to see this in action, give us a shout. We'd love to show you. Either way, that's been it. Thanks for watching, and I'll catch you on the next one.